Output. A galaxy drifts in the dark, its stars like glowing dust trapped in an invisible spiderweb you can't see, but you can feel by the way it pulls everything tight. That web is dark matter. It holds galaxies together, sculpts the cosmic web, decides where stars and planets can even exist. We can map its grip on the universe. We can measure its weight. But there is one thing it's doing that no one can explain. It refuses to touch anything. If dark matter makes up most of the matter in the cosmos, you might expect it to crash into stuff, to bump, to scatter, to leave clear fingerprints. Instead, it passes straight through stars, planets, and you, like you're not even there. Gravity is the only sign it exists, and that shouldn't be enough. The story begins with a problem that should have torn galaxies apart. When astronomers in the 1970s measured how fast stars orbit their galaxy, they expected the outer stars to drift slowly, like planets in our solar system. Instead, the outer stars were whipping around almost as fast as the inner ones. If only visible matter existed, those outer stars would fling off into space. But they don't. They're held by an unseen mass, like a hidden halo, wrapped around every galaxy. That was the first sign. Something dark, something massive, something invisible, is there. We see the same pattern on every scale. Light from distant galaxies is bent and stretched by gravity, tracing vast clumps of matter we cannot see. In galaxy clusters, galaxies move too fast to be held by their visible stars and gas alone. Everywhere we look, the universe is heavier than it appears. By now, we're sure. About 85% of all matter is dark matter. So physicists did what they always do. They tried to give it a particle. Imagine a zoo of invisible particles, like ghosts drifting through a crowded city. Occasionally, one might bump into a building, a streetlight, a person. If dark matter were like that, we could build traps deep underground to catch those bumps. Detectors filled with ultra-pure liquids. Crystals cooled to almost absolute zero. Layers of shielding to block cosmic rays and radiation. We turned the Earth itself into a dark matter net. Decades later, the net is almost empty. There are small hints, strange blips, claimed detections that disappear when other experiments look. But there is no clear, repeatable signal of dark matter colliding with ordinary atoms. The more sensitive our detectors become, the quieter the universe seems. That's the first part of the mystery. Dark matter appears to ignore every force except gravity. Now add the second part. Galaxies are not just piles of stars. They are delicate disks, spirals and bars, streams and rings. Computer simulations show that if dark matter particles collided with each other very often, those structures would smear out and collapse differently. If they never collided at all, galaxies would look sharper, more cuspy in the center. But when we compare simulations to real galaxies, neither extreme fits perfectly. Dark matter can't be strongly colliding, or we'd see it. It also can't be perfectly collisionless, or we'd see that too. It seems to live in a razor-thin space in between. Almost non-interacting, but maybe not quite. So here is the one thing dark matter is doing that no one can explain. Across the entire observable universe, in trillions of galaxies, dark matter is shaping everything, while almost never touching anything. It steers the fate of stars, but a single dark matter particle could fly through a light year of solid lead and never hit an atom. It sculpts the cosmic web, but its own inner life is a blank. It acts like a fluid of pure gravity. And nature normally hates pure. Every other particle we know is messy. Electrons feel electromagnetism. Quarks feel the strong force. Neutrinos barely interact, but not never. They scatter. They leave traces. Dark matter, on the other hand, looks like it has taken a vow of silence. So physicists are being forced into uncomfortable possibilities. Maybe dark matter is an entirely new kind of particle, like an axion, a feather light field waving through space, too gentle to ever strike an atom. Or a whole hidden sector, with its own forces and interactions, almost completely decoupled from ours. A shadow universe, stacked on top of ours, where dark matter collides, heats, and cools with itself, but we only feel its gravity leaking through. Or maybe the contradiction is telling us something even stranger, that our understanding of gravity itself is incomplete. Some researchers explore modified gravity, where the rules of attraction change at very low accelerations. In those models, there is no dark matter, just a force that behaves differently on galactic scales than it does in the solar system. These ideas can explain some galaxy rotation curves beautifully, but they struggle with others, and with the clean dark matter maps revealed by gravitational lensing. Either way, the universe is refusing to stay simple. We can see dark matter holding galaxy clusters together. We can measure its fingerprints in the afterglow of the Big Bang. We can simulate entire cosmic webs that match what our telescopes see, only when we add this invisible ingredient. But when we ask, what is it made of? Why does it refuse to touch us? The equations go quiet. Here is a thought experiment. Picture yourself floating in deep intergalactic space, far from any star. To you, it feels empty. A vacuum, but in every cubic meter around you, quintillions of dark matter particles may be streaming by, like a silent storm. For a lifetime, not a single one may ever hit a single atom in your body. Yet collectively, that storm is strong enough to bend the path of light from a galaxy a billion light years away. The universe is crowded with something we cannot feel. The one thing dark matter is doing that no one can explain is this. It is ruling the structure of the cosmos, while refusing to reveal its own. It gives galaxies their skeletons, but hides its face even from our most sensitive machines. Until we understand how something can be so present and yet so untouchable, our picture of reality will stay unfinished. Somewhere, in a quiet lab, a detector waits in the dark, listening for the softest possible tap from the invisible majority of matter. If it ever hears that sound, everything we think we know about the universe will have to widen, to make room for the world inside the dark. Tutulo. The one thing dark matter is doing that no one can explain, thumbnail_text. It won't touch anything, video_format. Discovery_mystery.